So when you solve for a variable, we've done all of the positive exponents and negative, but we haven't looked a lot at the square root. So if I were to solve this equation right here, what would I need to do? I need to take the what? Of both sides. Square root.
Wait, are you recording?
Yes. So if we're trying to get the exponent of x equal positive 1, what number are we multiplying the x? So 2 times what gives me 1?
25. X. 1.
Like, what's the reciprocal of 2?
Oh,
1 half.
1 over x2.
I thought it was negative 1 over 2.
Yeah, that's what I thought.
That's the negative reciprocal, but just the reciprocal is 1 half.
It's just 1 half.
So all of that to say that fraction exponents are just like taking the square root, cube root, fifth root. It's like making it smaller instead of making it bigger. So putting it in exponential notation is like rewriting it as 21 to the 1 half, or 15 to the 1/5, or 81 to the 1/3. So all it's doing is you see it in,
So do you just like get rid of that 5 that's right there?
you're just rewriting it. So these two mean the same thing. You're just putting it as exponential notation. So we're raising x squared to the power of 1 half. So square root of 5 is 5 to the 1 half. The opposite, going back to radical notation. Radical means it looks like what we saw before with the root things. So 4th root of 30. 7th root 28.
For this one, you put I outside?
No, because if you have an odd,
Is this solved?
odd can have a negative inside. So if you have an odd number here, it can be negative.
Oh. I saw a buzz on the calculator right now.
So if you have an odd number there, you can have a negative inside. Now, if the numerator is not always 1, so here we have x to the a over b. So if your number, it's not always 1/5, 1/3, 1/7, then you would rewrite it as,
So are those on 4, 5, and 6? Are those the final answers?
yes,
I have a question.
yes.
So it says you can't have negative on the odds, but what if it's even? What would you do?
You put an I out front if it were even.
Can you do 2 and then square root 5?
So here's what you do for number 7. The number that is the denominator, so 3, 3, 3, those go on the outside. So it would be the cube root of, and then the number that is on the numerator goes inside the radical, so 5 squared. Cube root of 9 to the 7th.
What does easy work?
Not unless it asks you to.
So we don't have to simplify, we just like...
Not unless it asks you to simplify. So if I were to simplify this without using a calculator, if it's just the square root of 32, you pull out the perfect square, which is what?
That'd be a 16.
16. So it would be 4 root 2. Now when you're doing like 11, 12, and 13, you're pulling out perfect cubes. For 12, you'd be pulling out a perfect fourth function, and then for 13, you'd be pulling out perfect fifth function. So are there any cube roots in 32?
16.
8. And so 2 to the 3rd power is 8. And so 8 times what is 32? 4. So I'm left with 2 cube root 4. Because it's like rewriting this as 8 times 4. This is a perfect cube.
Wait, what? So now we're looking for cubes.
Wait, before.
Because there's a 3 here.
Oh,
We're looking for cubes. So for number 11, we're looking for cubes. For number 12, we're looking for perfect fourth roots, I guess. I don't really know the exact.
2 cubed times 4 equals 32.
So are there any perfect fourth numbers in there? Like, is anything to the fourth power inside 32? 2 to the fourth. 2 to the fourth is what?
16.
16. Good. 16 times what is 32? 2. So when I pull out, there's a 4 here. When I pull this out, it becomes 2 fourth root of 2. What about 13?
Yes.
It's just 2.
No.
Because 2 to the fifth is 32.
So it's just 2.
So it's just 2.
Wow.
Because 2 to the fifth power is equal to 32. So with this one, I'm going to rewrite this as in radical form. So it's like saying the square root of 9 cubed. Now, whenever you're doing these without a calculator, it is always in your best interest to do the denominator first and then cube it. So the square root of 9 is what? 3. So 3 cubed is what?
9.
Cubed 27. Good.
27.
For number 15, I'm going to do the denominator first. Yeah.
Wait, so the 2 is like pointless to be there?
So
Wait,
it's
how did you
Why
do
isn't
the-
this-
it's like saying, here, I'm going to write it this way. I think it's easier. It's like saying this.
What?
I don't get that though.
Yeah, I still don't get that.
I don't get why there's a 2 out there. Oh, no,
Square
I
root.
think I just made it more.
Oh,
I just put a 2 there because in some of the examples it's not 2, it's another number. So
I'm confused. So do those cancel out?
you just end up doing the square root of 9, which is 3.
Well, where's the 2 go?
Right here, the square root of 9.
Yeah, but why is the 2?
Because it's the square root. The 2 is the denominator. So for 15, I'm going to say the fourth root of 16 cubed.
64.
So the fourth root of 16 is what?
4.
2. 2 cubed is 8.
Why are you not using 16 now?
Okay, everyone listen. Put your pencils down. Put your pencils down and watch me. When you have something like this, I'm going to rewrite it as the fourth root of 16 to the third power. Are you okay with this so far? So I take the denominator, and that's what root it is. So if it's a 2 on the denominator, it's the square root. If it's a 3 on the denominator, like here, then it's the cube root. If there's a 4 on the denominator, it's the fourth root. And the number that is the numerator goes on the outside. So I'm going to do the stuff in parentheses first.
Miss Thornhill, would you please send John Michael to the front?
Yes.
He's leaving.
Yes. So the fourth root of 16. Stop talking. The fourth root of 16 is 2. That's something that you do need to memorize because 2 times 2 times 2 times 2 equals 16. So I just replace the stuff in parentheses with 2. Then I raise it to the third power, that is 8.
Oh, okay.
So now the next one, cube root of negative 27, just raised to the first power because it's 1/3. So what's the cube root of 27? 3. And it's a negative, so negative 3. That is okay. There does not need to be an I because it's an odd exponent. So it's like saying negative 3 times negative 3 times negative 3, which gives me positive 9, negative 3, negative 27. So try number 17. I'm going to rewrite this as the square root of 4
Why is it negative 3, not 3?
because it's negative 3 to get negative 27.
Bye.
Bye, Johnny. I love you.
Have a great time.
Impossible, I love you.
So square root of 4 is 2. 2 to the fifth power is good. Next one, cube root of negative 1 raised to the seventh power. So cube root of negative 1 is positive or negative 1? Negative 1 because odd.
Can be, it's an
Odd. Negative 1 to the seventh power is -1. Good.
Hey, first you try to get rid of the.
So I'm going to write this as the cube root of 125
I got it right.
squared. Cube root of 125 is what? 5 squared.
How did I get that right?
So now I'm going to use my exponent rules to simplify. Number 1, what would I do with the exponents? Side by side, power to power.
Oh my god.
Side by side. Add.
Would it be 1/6? I mean 1/5, sorry.
What's 1/3 plus 1/2?
2/5.
Oh no.
I need a... Whoa, I can't do this.
It's 5/6.
So x to the 5/6. You should be responsible to know how to add fractions. And multiply fractions. I know I'm asking a lot here. Multiply. 15 times 1/5 is what? 3.
Now this one is multiply.
What's that?
Right?
3 is multiply.
Wait, what's the little 6 up there? Why is there 6?
Common denominator.
No, it's like, that's not in the problem. It's just the answer is x 5/6.
For the 16,
Yeah.
you just do. Wait.
So 1/2, I'm going to distribute it. 16 to the 1/2 is what?
1/16?
No.
1/16?
Square root of 16.
4.
4. Because it's like taking the square root of 16.
Why are you taking this?
Because it's raising 16 to the 1/2 power. So when I distribute 16 to the 1/2 equals the square root of 16, which equals 4. Okay, this one. I have a negative fraction exponent. So it's like doing 1/25 to the 1/2. This 25 to the 1/2 becomes what? 5. So 1/5. So negative exponent does not mean negative number. It means flipping it to the bottom.
Oh no. You put it.
Okay, number 5. What do I do? Add, subtract, multiply. But what do I do with the exponents?
Oh, yeah.
Subtract.
Subtract. Double whip.
But you have to first make them
I'm
equal.
gonna bring it back down.
So I'm going to change this to be 4, 6 minus 1, 6, which is 3, 6. When it's division, you subtract the exponents. X to the 1/2 or square root of x. So with this one, I distribute the 1/3 and it becomes x squared. With the 125, it's like saying the cube root of 125. So that's why I get 5. It's not 125 divided by 3. Don't do that. And then y, -3 times 1/3 becomes -1. To make it positive, I have to bring it up to the top. So this becomes my final answer. Yes, ma'am? It's x to the 6 times 1/3 because I distribute. So 6 over 3 becomes 2. No, it's you multiply the exponents because it's a power to a power. Yes. So if I am solving for x, basically I'm trying to get x by itself. So I want to get x by itself. Then I want to raise each side to reciprocal power. So for instance, on 8, gonna subtract each side by 13 and I get x to the 2/3 equals 4. Now I want to raise each side to the reciprocal power. So the reciprocal of 2/3 is what? 3/2. 3 over 2. And that means that these will cancel. And it becomes x equals 4 to the 3 over 2. But I'm not done because I want to solve it out. So I would do the square root of 4, which is 2. And then 2 to the third power is 8.
Wait, say that again?
So I rewrite this as the square root of 4 to the third power because I put the denominator here and then the numerator goes on the outside.
Where's the 2?
Yes.
They just like drop
This is the 2. Square root means 1/2. 2. Yeah.
Well, yeah, I just helped you.
Okay, for number 9, I'm going to divide each side by 3. What is 375 divided by 3?
125.
125.
125.
Gonna raise each side to the reciprocal power.
And then it would be 125.
So I'm gonna take the cube root of 125 and then I'm gonna square it. So x equals,
15.
what's the cube root of 125?
Oh, I put them on the wrong side.
5. 5 squared. Okay, number 10. I'm gonna divide by -2. Watch it and find out. So x to the 3/4 equals 8. Then I'm going to raise each side to the reciprocal power. So reciprocal power, I'm going to take the cube root of 8 and then raise it to the 4th power. So 2 to the 4th is what? 16. 2 to the 4th, yeah. What about number 11? What would I do here to get rid of this -2/3?
Multiply by 3.
Good, Gabby.
Multiply by each side by the reciprocal. That's how you get rid of fractions. So I have x to the 1/5 equals 6 over 2, which is 3.
Students that need to go to the guidance office.
Okay, what do I do now? I need to raise each side to what power? 5th. So 3 to the 5th power is whatever 81 times 3 is.
It's 243.
Good.
I got it for you, Zach. I still believe that.
Okay, last 2. I'm gonna, since you have this stuff in parentheses, the only way to get rid of it is to raise to the reciprocal. So raise each side to the 3/4. Then you're gonna do the stuff in parentheses last. So I'm left with x minus 4 equals 81 to the 3/4 is the 4th root of 81, and then cubed. So what's the 4th root of 81? Not 27, 3. Because 3 times 3 times 3 times 3. 3 cubed. So x minus 4 equals 27 plus 4. 31. Same thing for this, but I want to do, remember you do PEMDAS backwards, so subtract 3.
I saw the promise. She's upset.
There we